Hello everyone, in this video we'll be solving problem number 1 to sum. The problem statement is given an array of integer nums and an integer target, we need to return the indices of two numbers such that they add up to the target. In example number 1, with 4 numbers in the nums array and the target set to 9, if we add 2 and 7, the output is 9 which matches our target. Hence we return 0 and 1, that is its corresponding indices. In example number 2, we are given 3 to 4 as the nums array and the target is 6. The output is 1 and 2 as the corresponding values 2 and 4 give us the sum as 6. As a follow-up, the problem statement is asking us to solve the problem with a solution better than O of n squared time complexity. Let's switch to whiteboard and discuss multiple approaches in solving them. One way to solve this problem is by running nested iteration. As the problem statement is asking us to calculate the target using two numbers, we can run a nested iteration one inside other. One will be pointing at number 1 and the other will be pointing at number 2. We'll calculate the sum of both of the numbers. If the sum matches the target, we'll stop the iteration and return the indices, and if not, then we'll continue the iteration by incrementing both of the pointers. With this solution, our time complexity is O of n squared as we are running nested for loops, and the space complexity is O of 1, that is constant space. As we are not maintaining any collection with the sums, we are simply calculating the sum and checking if it matches the target. One improvement that we can do to this solution is to sort the array first and then run the loop. The reason is if the sum of two numbers is already greater than the target, if we are continuing the iteration further by incrementing the pointers, all of the remaining combination sum will also be greater, so there is no point in continuing the iteration further. This approach improves our previous solution, but if we think about the worst case scenario for time complexity, it will not change. I hope you were able to understand this approach. Now let's think about an optimized solution. For an equation like this where we are adding two numbers and getting the total, if we know any two values, we can easily calculate the third value. If we apply the same logic to our problem statement, we are given x and z and we need to figure out if there is a y in the input array. All we need to do is iterate through the input arrays, set it to x, compare it with z and calculate y. We'll save this y in a hash map and continue the iteration. For every iteration, we'll check if the current number exists in the hash map. If yes, it means that we have found x and y in the array, so we'll stop the iteration and return its corresponding indexes. If not, then we'll continue the iteration until the end. Let's run a couple of simulations to understand how will this work. In the hash map, we'll be saving the number that we need as a key and the current number's index as value. Starting the iteration as I is equal to 0, the value is 2. Comparing it with the target, we are looking for the value on number 7 to get the total of 9. As it does not exist in the hash map, we'll add it to the hash map with the index 0. I'll swap the value 7 with 11 in the input array so that we can run a couple of more simulations. After incrementing my pointer, I is equals to 1, which is now pointing at 11. We'll check first if 11 exists in the collection. As 11 does not exist, we'll calculate the difference, which is minus 2, and add it to the hash map. After incrementing my pointer, I is equals to 3. Now we are pointing at value 7. As 7 exists in the hash map, we'll take the corresponding value from the map and the value of I, combine it into a single array and return it as an output. The value in the hash map represents the index that we need to be added with 7 to get the target 9. As we found a valid pair, we can stop the iteration here and return the output. With this solution, our time complexity has been improved to O of n as we are only iterating through this given collection once, and the space complexity is O of n as we are maintaining this hash map with the numbers that we need and its corresponding indices that requires it. Let me show you how we can implement this using C#. Here is the C# solution. I start by initializing a dictionary of type int and int to calculate and store all of the values that we have already seen or visited. I then start the for loop starting with I is equal to 0 until the end of the nums array. I then calculate the difference that we need. If the diff exists in the map, then I'm grabbing the value, including the current value of I, into an array and returning it. And if it does not exist, then I'm adding it into the collection. The problem statement states that there is one pair in the given array whose sum will be the target that is given to us. So the results array will never be empty. This code, when submitted on LeetCode, beats 98% of the submissions in terms of runtime and 16% in terms of memory. Thank you for watching this video. I hope you were able to understand this explanation and the code. The link to the code is available in the description below. Feel free to check that out, and I will see you in the next one. Thank you.